Okay, hello everyone. This is Adrian, and I am the creator of this procedural infinite runner project, which is a procedural world generator in 3D for Godot. And I wanted to do this little video to introduce a little bit the project, give a quick overview of all the features as they stand right now, because I have actually updated it a lot since I first posted it. And recently I've added a lot of features, so I wanted to give a little overview in video of each of them. And also I wanted to present a little bit how the code and the project is structured in Godot, because I guess it's not very straightforward and maybe not super easy to understand since this is a full project. But this video is going to be an overview only, so it's not going to be a full coding class, but it's going to assume that you know the basics of C# coding and Godot. So, as its name says, it's a random world generator which can generate a terrain to infinity at complete random, including the terrain, the objects you can see on the map, the water logic, and all the stuff like that. Even the clouds now, which from the latest update, are also randomly generated. Along with the terrain generator, I also wanted to add a small gameplay, TPS gameplay, which is intended mostly to showcase the terrain, so that people can navigate the project without too much hassle and get started very quickly. But it's not a full game, so there's no gameplay per se, but you can do some walking, some flying, etc., etc. But this is mostly to demonstrate the terrain. So the project is fully open source, MIT license, which means basically that you have to give me credit if you want to use the code for your project. If you don't, it's fine. If you do, it's really appreciated, right? And the objectives I had for developing this project was first, that it has to work on mobile, and second, that it has to not have any dependency to anything. So this is pure C# and Godot shader script, nothing else. So you don't have any dependency, you don't have anything like that. So here we go. The project, as you can see, is split into a few scenes. There's not a lot of them, but they all have their own purposes. So the main scene is about having all the game manager, software manager, like all the big managers, because I like to do that when I have a project, like have managers of the managers, just in case we need it. This might be overkill for a small project, but it can get useful down the line, I guess. And also the UI, because the UI is not very complicated, so I didn't give it its own scene. So it's just standing there, and you can switch to 2D to actually see what it's about. So in the UI, you have the point counter, I call it the mojo because I didn't know what name to pick. I don't like power. The mojo is like kind of the skills you can use, like you can either run, you can either fly. You have the distance counter, you have the compass also, which has its own little script here. And time is for the time of the day. The second scene is world, and world is spawned in this script, I think. I'm not going to open C# right now. I'll do it a little bit later, but basically the first thing the game manager does is to spawn an instance of world. And then world is the actual script that generates everything. So including the mesh, including the objects, the material, the water, like everything. Here we have the world environment. The world environment is a standalone script, so you really can copy and paste it into your own project, and it's going to deal with generating the sky. So in the sky is using the procedural sky kind of default of Godot. So you don't have a lot of options, but it's enough for what we're trying to do. So basically, you can set up a sunlight. You can set up a not in the script, but in the basic procedural sky, you can set up the color of the lights, and you can set up a bunch of things that make the reflections. Then on top of it, what I added is this environment manager. And what it does, it allows you to set up a few different sky colors and sky intensities, and the time of the day they will be used, like they will transition to. You can also set up the speed, like how many minutes go for a day, stuff like that. So it's really self-contained, and you can copy paste it anywhere. And the last thing it does is also to generate clouds. So you can have there's a bunch of different setup of clouds for They're basically determined at random every day. So you can put your own cloud setup. You can set up like cloudy skies, like spotty skies, and like no clouds at all. And every day at midnight, it's going to determine what's going to be the cloud setup for the day. Second, we have the playable character. The playable character is a very simple TPS character. So the Godot model I used it from, I think the link is in the project. It's in the README file. But basically I pulled it from the internet, and then because it had a bunch of animations ready to go, and so I directly used it and put the script for the playing character on it. Since it's a TPS view, this is also where you find the camera that's going to follow the character. So I try to put as much basic TPS stuff. You can like move forward, sidewalk, you can jump, you can fly and glide, like basic stuff like that. So this is just to showcase the project. If you're interested, you can open like the main character scene, and you can check it out. It's got a bunch of stuff. Yeah, one important thing though is that it contains, because the camera is there, so it contains a few shaders that are used for the project. So there's a sharpen shader, that's the basic shader we have to like display the world, because the sharpen effect always looks a little bit better. Some people like it, some people don't, but I tend to like it. If you don't like it, you can just turn it off. And you have the underwater shader. So this is, as soon as the camera goes underwater, then this shader triggers, and it's got a bunch of parameters to simulate the underwater effect. Here again, it's not super advanced. It's just like the basic of the basics of what you would need to show underwater, but it's meant to be extended. You have also the animation player, animation trees all ready to go depending on what you do. I'll open C# in a while, but right now I just want to go through these scenes. And then of course we have the mobs manager. It's taking care of spawning the mobs, but it's not very interesting. I mean, if you're interested in any of the things I'm mentioning here, you can just drop a comment and I might do a specific video dedicated to it. I'm putting a lot of effort into commenting better the code and making it a little bit cleaner and easier to understand, but it's still gonna take time, right? Okay, so we have the most important thing, the terrain manager, which is where everything is done. So the terrain manager is split into terrain, actual terrain manager, and terrain details manager. So the terrain manager handles all the different scripts that need to come together in order to create the final terrain. And the terrain details manager, it's actually pretty badly named. I should rename it or just delete it altogether, but basically it handles the actual spawning. But I guess, yes, so the last thing I will mention before we go to the code is every single object that is going to be spawned has its own scene. The reason for that is that every scene, every object you want to spawn on the map needs to have a world item model script attached to it. The reason it needs the world item model is that the world item model script is part of this world item big class. It's a subclass of this big class, and the world item thing is supposed to handle everything regarding the spawn. So the terrain manager knows that, well, that this item should be here. So we have a position, we have maybe generated a random scale for it, some light rotation or tilt, and some other characteristics of it, depending on the game you want to build. And then this world item will send all the information, all the requests it needs to the model. You also have like a base shell function if in case the LOD is changed, and a bunch of things like that. So it's important for any random generated object to have this world item model. There's a bunch of different scripts that are all working together in order to create the final landscape. So you have, for example, the map generator, the mesh generator, the noise, the terrain chunk, and other scripts that are all combined together in order to create the final terrain, the final landscape you can see. So if you want to know about their different roles, there is a comment in the beginning of each script, or you can ask me, or you can simply watch the code and try to figure it out. So there's a lot of similarities with the original tutorial, but there's also a lot of things that I have changed either to fit the project or to fit Godot. So the terrain manager is designed to run a function every second that will do the following things. So I made a little list so that we don't have to go through the code, because it's better explained in plain English, I think, and it's faster this way. So every second we first determine what chunks do we need to spawn, depending on the location of the player. So which chunks of terrain, which tiles are close enough for us to even consider spawning. After that, once we have a list of the chunks we need, we generate the noise maps for each chunk. So the noise map is basically a 2D, a flat map with a bunch of elevation data. And then we generate the items depending on another random script. So we don't spawn the items, we just generate them. So we generate their location, we generate a bunch of random data depending on the stuff we set up in the world item. So for example, the rotation, the scale, the things like that. But we don't spawn it yet. Because 3, we actually make the chunk. So we spawn the chunk object. Same chunk is a script, is a C# script that contains all the data of each tile of terrain, including the LOD, the objects, the height map, the water stuff. This is a general container for all this stuff. And then we populate, so we put the noise maps we generated in part 2 into the terrain chunk. Let me write it. .cs. If you want to look for it, it's terrainchunk.cs. All right. Okay. Fourth, we ask the question, what is our LOD, depending on the distance from the player. So do we need a very precise mesh, or do we need a more distant mesh? Or do we actually even need a mesh? And then if we do, we actually ask Godot to make the mesh. Like, there is a whole script that takes care of it. 6, we spawn the items and the water. So this is the most heavy part because it has to actually do instantiation in the engine. And we only spawn the water if required, which means if this tile of terrain actually contains an elevation that is below 0. Otherwise, we don't bother spawning it. 7th, after everything is done, we also clean up the chunks that are out of view, because we will keep a list of all the chunks we have generated so far, and if one chunk happens to be out of this list, then we will first make it invisible, and if enough time has passed, then we will simply remove it so that we can free memory space. So this is basically what happens every second in the terrain manager. Okay, now I'll introduce a little bit the map generation settings because it's kind of important. It's probably the first thing anybody is going to look for. And the map generation settings contains all the setup, initialization of the data, what the terrain manager will use as an input. So it contains, the first thing you can see is highest point, lowest point. So the terrain generated goes from 200 to -200, with the 0 being the sea level. There is a precise reason that I use 200 to -200, but I will not mention it right now. And then we have default values, which is just a function that returns the default values we are using right now. And it does two things because the terrain manager needs two things to start generating the terrain. First, it needs to know what kind of noise we will need. And to do that, we have terrain pass. So terrain pass is basically the noise setup. So it's a bunch of stuff that's like the scale of the noise, the frequency, octave. So these things are just basically it's just how to generate the pertinent noise. And you can actually set up several passes that will be blended together with blend type. So you can mix, you can add, and well, maybe we can expand it to have many more blend types. And this is to introduce some kind of subtlety to the terrain generation. So for example, you can set up this pass to only kick in elevation such and such. until elevation such and such. So this is basically to make the terrain more interesting. It's still very simple. I guess it could be made more interesting, but for now, I guess that's enough. That'll have to do. And yeah, the second part is the world item settings. So all the objects we have, all the meshes we have turned into world item models need their own settings. So this is where we create and set up the settings. So we use the name and the path. So the path is basically the name of the scene, so that Godot knows where to find it. And then we have all the random generation data. So the concentration is how much of this stuff do we want. So concentration 3 is actually a lot. So this is all the trees you can see in the demo use concentration 3. So this is actually the most I use in this version. You can set up the randomized alt angle, rotation, set a minimum size, maximum size, etc., etc. So basically, it's all the you declare here all the items you want to be spawned in your map, and then once you have initialized all these world item settings, you put them into the natural object container. So natural object is a list, and then the random generator will know to fetch this list and use the concentration value to sprinkle it around the map. So yes, you cannot do it in the editor. The reason is that I just really don't have the time to do a proper plugin thing. So for now, it's only through code that you can do it. But like, maybe at some point I will do it. But for now, I just don't have the time. So lastly, let's talk a little bit about the terrain and the terrain shader and how it is generated. We use the vertex color data in the mesh we generate to actually determine the different textures we will use. Because in the shader we use for the terrain material, we have actually 3 levels of shaders. We have the dirt, and we have the grass, and we have the sand. So each layer of shader has the albedo material, which is pretty basic, the roughness material, which is also super important, and the normal material. We use the vertex color to do a blend of the 3. We could have 4, we could have 5, but it would increase the complexity and also the complexity of the vertex color generation. So for now, the logic I use to generate the vertex color is everything under elevation 2. So remember how the terrain goes to 200 to negative 200 and 0 is the sea level. Then the sand is generated at roughly elevation 2 or 3 because this is the sea level, right? And for the rest, I generate the grass or the dirt. The dirt being generated exclusively when the terrain is too flat. So anything that's flat will use the dirt and the rest will use the grass. There's no special logic to it. It's just a way to test how everything works. But of course, this is completely customizable depending on what you want. So to simulate the water shader, I used a little trick, which is to basically reuse the height map from the terrain and plug it into the water to tell the water how deep the terrain is down under, so which means how deep the water is. And so we can use this to make a distinction between shallow water and deep water. And this little tricks is very good, especially for mobile, because it is very light. So it doesn't need a lot of computations to work. But the limitation is that you cannot move the water, so it's not going to be dynamic. So there's a very simple buoyancy that works with the water and any physics asset you want to use it with. So currently it's only working for crits, but it could be working for any kind of physical asset. It doesn't work with the character though. So the tower is one of the latest addition to the assets I put in the project. The reason is that I wanted an indoor asset just to test and try the transition between different environments. So you can check out the environment is changing as we get inside and as we come outside. And I guess you might be thinking like, duh, of course, what's so special about it? Well, especially in procedurally generated projects, the engine doesn't make any distinction between indoor and outdoor. So you have to kind of program it manually. Otherwise, it's going to constantly use the environment you set up for the outdoor, which is going to look very strange. So that's it for this very rough overview of the project. If there's anything I missed or anything you'd like to dig deeper into, you can tell me in the comments and I'll see to make a video dedicated to it. Thank you and have a nice day.